Hi, in this video let us discuss about delete at a given position in a circular linked list and its implementation in C++. So the input for this particular operation is the list and the position where we are going to delete, and let us consider a circular linked list with 5 nodes and let the position of deletion be 3. How we will work we will discuss. So the concept that we are going to use for deletion is we will have a temporary pointer and we will make the temporary pointer to point one position less than the position where we are going to perform the deletion. Okay, and then we will be carrying out the operations. This is the basic idea. So if I want to delete the node at position 3, I have to place the temporary pointer here and I have to make the changes. This next part should be changed to this next part, and this node should be removed, right? So how I can start the algorithm is I can make initially temp to point to the first node and let counter be there and let it be equal to 1, and we will move this counter while counter is less than position minus 1. Okay, and then what we can do is we can check whether this temp is valid, right? Valid in the sense, I mean, like it should not move beyond the last node. When this will happen is if the position is greater than the number of nodes in the linked list. For example, if position is 7, this is an invalid thing. I should prevent the pointer from moving to and coming to position number 1, right? It should not delete the node at position 2. If I am not going to check that may happen. So I will have one more condition in the loop checking whether I have reached the last node. In a circular linked list, we can identify the last node by knowing its next part is equal to head, right? And also we can do basic checks like if position is less than 1, because we are going to give positions from 1 only. So if it is less than 1, then we will raise some kind of indication. We will communicate to the callee function that this is an invalid thing. That's the idea. And two special cases that we have to consider are when the list is empty, we have to do something. Okay, that is we have to return -1 and communicate failure, and when the position is equal to 1, right? In that case what we have to do is we will do something more than what we generally do, like we have to change the head, and if it is the only node then we have to make head equal to null and so on. These two cases already we have dealt it in delete beginning, so we will call the same delete beginning function for these two cases. So let us formally write the algorithm. Input is the list and the position. If list is empty or position equal to 1, then we will call delete beginning and return whatever that particular function returns. And then otherwise we will make temp equal to head and counter equal to 1, and we will be moving counter to position -1 node, and also during this traversal we will be checking temp is not the last node. In that case, if these two conditions are satisfied, move the pointer and increment the counter. And if this is outside the loop we are checking if the counter is equal to position -1, then in that case it is valid. So we will be doing step number 8 to 11. But before that we have to check one more corner case. This is the corner case when the position is 6. Actually in the given example there are totally 5 nodes, right? If the position equal to 6, then the node temp will easily come to position number 5 and waiting there to do deletion, but we are at the last node. We cannot delete the 6th node because there is no 6th node at all. If we are not having any check there is a risk that we may lose the first node. So this condition also should be checked. So let us have another one point at temp1 and let it point to the first node of the next node of the temp. And you will be checking whether temp1 is head. If temp1 is head, you will communicate failure and turn -1. Otherwise you have to, these are all the steps that we will be making when position is valid, right? So what we will be doing, next part of temp will be equal to next part of temp1, and store the data part in a variable d, free the memory pointed by temp1 and return d. Let us implement this algorithm in C++. We have to make declarations that is already done. In delete position we are passing integer alone because we are doing object-oriented programming. It is not required to pass the list explicitly as we are doing it in C++. I have made the declarations of temp1, counter and d. The first thing what we will check is if position is less than -1, right? We have to communicate failure. How we are going to do is, we are going to do that using a global flag. So let us set the global flag. Actually, before starting the function, we should reset the global error flag as we discussed before. And if this condition is satisfied, then you have to delete the error flag and return -1. And you're checking if list is empty. Okay. If list is empty, okay, or position is 1, right? So let us check, or position equal to 1. In these two cases, we will just call delete beginning and return whatever is returned by that particular function. And otherwise, we will be making temp equal to head and counter equal to 1. And we have to move the now temporary pointer to the last node, and also we should be checking, okay, so not last node, to node at position -1. During the traversal, we have to check whether the last node is reached or not, right? So while temp next not equal to head, right? This is the check for last node, and counter less than position -1, right? In these two cases, if these two cases are satisfied, then we should increment the counter plus plus, and then temp equal to temp next. Be moving the temp to the next node, and this one we will take up before step number 8. We will do before that one more corner case check. Okay, temp1 equal to temp next, and you have to check if temp1 is head. If temp1 is head, then we can understand that, okay, temp1 equal to head, right? If temp1 is head, we can understand that we are trying to delete a node which is not at all there. So in this case, I have to communicate the failure. So delete error flag equal to 1, and I can return -1, right? And here I have to check the condition. If counter is equal to position -1, what we have to do? We have to make the temp next equal to temp1 next. This change we have to make. The link we have to establish, and d is equal to temp1 data. We have to make that, and free the memory, free temp1, okay, and you have to return d. Fine, let's finish the loop. So let us check the code, compile the code and check. So okay, so I have missed this star here, right? So because of that I am getting some errors, and okay, all those errors are gone. Now I have got this error because of free. Actually we are doing C++ and we have to use the delete operator. That is the mistake here. So let me call delete, and its operator, so no need of braces. And let us compile and check. Yeah, it's fine. Let us execute and see here. What we are doing is, we are having a linked list with 5 elements, 1 2 3 4 5. I have just made a simple list. Consequently 1 2 3 4 5 is there, and I am trying to delete 2. So the delete operation is successful, and we are getting the list without 2. Now let us try to delete node number 6, value number, okay, node at position 6. Now it is printing the deletion failed, and it is printing all the elements, right? Let us try to delete 7. Once again it is printing deletion failed, and all elements are still in the list. If you try to give at position 0 also, you will see that everything is getting printed, deletion failed is coming. Okay, so the code will be shared in GitHub. Thank you.